Okay, so these are the construction sequence. So by now, what we go through is that we go through what is the spatial characteristics of a high-speed rail system, and what are the elements which require to be constructed, and the construction sequence of all these elements. Now, the first element had to be constructed is the civil work. Let's look at the civil work which had to be constructed. There are three types of the civil work which has to construct to support a high-speed rail system. Common one we have seen is the earthwork, which the track and all these power system will be built on top of it. Then there are bridge and viaducts which support all this powering system, track work on top of it. And then there will be tunnels if you have mountains in that region and you want to go through the mountains. So you have to construct tunnels to go through all these mountain ranges. Okay, so these are the three types of the civil work which you have to construct in order to support the track work on top of it. Let's look at how often they are being used. This is some kind of study by the Shinkansen. This actually trying to delineate what type of the structure, what type of the civil work structure were constructed to support a different line of the Shinkansen at different time of the construction. So let's look at the first Shinkansen, which was completed in year of 1964, the Tokaido Shinkansen. Let's look at this Shinkansen line. And what we can see from this Shinkansen line is that the majority part, 291 kilometers of it, is constructed with earth structure. So it is the track is sitting on earth structure, and 174 are sitting on bridge and viaduct. So majority, or maybe 60% of the structure are earth structures, and the rest of them are on tunnel. And this is the tunnel usually is depend on the mountain range you have to go through. Okay. So that is the first Shinkansen, 500 plus kilometers. Among them is the distribution is 291, 174, and 86. Okay, so this is the first Shinkansen, mostly constructed with earth structure. The second Shinkansen line, which is then the other way around. The viaduct is almost 3 times. Viaduct is 3 times more than the earth structure. So if there is a choice between earth structure and viaduct, the designer tend to select the more viaduct and bridge. And look at the third one, which is even newer than the Sengyo Shinkansen, which was completed in 1982, with the experience built up. Actually, most of this high-speed line is built on viaduct. So a viaduct is almost 20 times more than the earth structure. The third one, the Joju Shinkansen, almost has no earth structure. It's basically 2 types, viaduct and then the tunnel. So the most recent one is still the same, more viaduct. This is the shorter one, but it's still more viaduct than the earth structure. So what you see here is there is a trend. There is a trend. This viaduct structure being used more often in recent, in newer Shinkansen. And why is that? The most one of the factor, of course, is because the earth structure will use more land. Also, earth structure will create a separation of the land. And also the earth structure is subject to the weathering, flooding, and the maintenance cost is higher. And although the bridge and viaduct has a higher construction cost, still becoming a preferred selection for Shinkansen construction. So that seems is a kind of a trend. And actually, not only in Japan, actually a lot of places are also the same. Viaduct and bridge are the preferred civil work structure for high-speed line. Okay, so what's this? Let's start with the bridge and the viaduct construction for high-speed rail. Again, because it's big, because it's the sheer size of the construction time is very important. So how to construct this viaduct quickly or efficiently is a subject. And technology has developed to construct this viaduct very efficiently. This is a part of the Taiwan high-speed rail which goes through southern part of the Taiwan. And in today's lecture, I will use a lot of these photo from the Taiwan high-speed rail construction because I spent 7 years. I spent 7 years in participating and managing the construction of this project. Okay, so the construction of this viaduct, basically, the new technology is to construct as a precast box girder. And then after you construct this precast girder, and then you can launch it with some special machine. And I will give you a detailed description of how this is done. The design of this girder is a precast girder, and so you have a close section with a minimum material, minimum concrete and steel, and you can support the high-speed line. Also provide the rigidity which is required for the high-speed rail operation, because the train is running on the girder. It cannot allow too much of the deformation, and that is the reason. That is another reason you like to use the box girder, because it's very efficient in providing this rigidity of the structure. Okay, so this type of the girder in the construction of the Taiwan high-speed rail, it starts with the 30 meter in length. So usually it was most of them are designed for 30 meter in length. With the more advanced construction, better quality, better manufacturing skill, nowadays you can construct 40 meter, okay, 40 meter in length. In other way, if you can construct longer length, then you can reduce the piers which have to support it. And if you increase the span from 30 meter to 40 meter, you can reduce 1/3. You can reduce 1/3 of these piers and piles you have to construct in order to support the girder. So that is very efficient. So there are a lot of this kind of the design construction technique being devised in order to mechanize or efficient the construction of the high-speed rail. Okay, now let me bring you through how this is being concept, or how this is being constructed. Okay, this is a casting yard of the girder. Okay, and usually you work at factories here with all the formwork inside, and you cast your girder inside. I will show you how to cast it. I will show you the formwork which is used. Okay, and after this is girder is being cast and it is being pulled outside to store for to curing or to store for construction. Okay, and so you have a gantry here to lift up the girder, okay, onto this viaduct, which is on the main line, and you can lift this girder up and putting on the transporter. This is a transporter which can transport along the line, and then there's a launching machine at the end which will launch the girder. Okay, so this is the type of construction technique used in this so-called full span precast launching method. Okay, let's look at the molding used for casting the girder, and this is the outside mold, which you put the outside mold and start putting all the rebar in. After you put the rebar in, you start putting the inner waterproofing membrane, or you start putting in the inner rebar, and then you can cast the concrete to form the girder. Of course, this is the pre-stressed one, so you have to do the pre-stress and after the pre-stression, and then you can start concreting. Okay, so these are all the pre-stressed wires which comes out of here. Okay, so this is the fabrication of the girder. Now I like to use animation to show you how this is done after it is being cast, and then how it is bring up to the viaduct which was constructed on the side. Okay, so this is the casting yard, and after the casting, okay, in this ammunition, they put out the cast girder, okay, with the formwork at this time. Okay, so the formwork is still on it, and what we will see is how the formwork is removed, and how this girder is being lifted up onto this viaduct which already constructed, and how it is moved around this, and how it is using launching girder to launch it. So that will be in this animation. So let's look at it, the sequence. Okay, so what you are seeing now is the main drum inside the precast girder is moved out, and then formwork is moved out. Okay, now gantry move in. The gantry move in to lift the girder up. So the gantry move in to lift the girder up, and then try to move the girder onto the a viaduct which was already constructed. And then on the side is the transporter. On the side is the transporter. Then the transporter will move in. So now what you are seeing is the transporter move in. And transporter move in and then start picking up. The transporter will be picking up this girder. Okay, so girder is being picked up, and then the girder will be transported along the viaduct forward. Okay, so now the girder, the precast girder is being transported to the location which had to be launched. Okay, so this is the so at the end there is a temporary girder which allow the transporter to run over it. Okay, and then when the girder is in the place, the temporary girder move away, and then the permanent girder drop in the place. Okay, and then the transporter is ready to move back. So the transporter will move back to the casting yard and pick up another girder and move on. Okay, so this is the construction sequence. And your question may be, Then how fast you can construct this? Usually it's about one girder per day. The whole cycle take about one day's work. So by average, every day you can construct 30 or 40 meter girder. In the most busy time, the Taiwan High-Speed Rail company was being able to construct 8 kilometers of bioduct per month. So 8 kilometers of this per month with the several sets of the machine they have. So that is how fast this bioduct can be constructed. Totally, there are 212 kilometers of bioduct being constructed in the Taiwan High-Speed Rail project. Okay, so let me show you another way of transporting or construction the girder. This is another machine which is used, and this time is different. The transporter which transport the machine, transport the girder, will not do the launching. There is another launching machine, and the advantage is allow the transporter being able to go back and pick another girder up, and you can speed up the construction. So the transporter do not have to be waiting here to launch the girder. Okay, so basically you have a launcher. This is a launcher which you will move forward and stand on this, form a temporary support here, and then the transporter will transport girder here. So this will pick it up and then launch it, set it in the pier and making the connections. Okay. So let's look at how this is done. Okay, so what we see is the transporter transported the girder in at this point, and then the launching machine is moving out. Okay, so the launching machine move out and then stand on the position, and then the launching machine also start trying to pick up the girder. Okay, so the girder move in, the launching machine pick up the girder and start moving the girder forward into the position. Now it's in position, and it start lower it, and you can see the transporter already go back this time. Okay, and then the whole cycle completed. Okay, so again, this is another way of launching a girder, and this is very often used in the construction of the bioducts in the high-speed rail system. Then another structure would be the tunnels. Civil structure constructed for this will be the tunnels, and the construction of the tunnel is not that much different from other tunnels. The major difference being high-speed rail tunnel had to be designed specially for releasing this pressure built inside the tunnel. So it's the tunnel design which has to do with it, or reduce the aerodynamic pressure which built up when the train entering into it. So the high-speed rail tunnel generally are bigger size than most of the highway tunnels and so on and so forth. Okay, the construction also had to be sequential in order to efficient that. This is a diagram which used in the Taiwan high-speed rail construction, and it's a so-called top bench method. So what you construct the top bench first, and you construct the lower bench later on. And there is a construction sequence. So if you are interested, you can go through this and try to look at the pictures and realize how different steps are followed from with each other. Okay, in order to finally cast the lining and complete the construction. So these are the construction sequence for construction the tunnels. What I show you here again is a picture of the Taiwan high-speed rail construction. This is the waterproofing membrane being put in place, and from what you can see here, large work platform had to be built in order to install all this. Also, large platform had to be used for inserting the rebar. So the waterproof membrane is behind, and these are the rebar. And then later on, you have inner mold comes in, and then you can start grouting it. Okay, so this is the inner mold which I show you. I talk about. Okay, so this will move into the after the rebar and membrane is in place, and you start grouting from all these holes. Okay, so that is how you construct the tunnel with lining and waterproof membrane. And then, of course, there's this earth structure which require a lot of quality control, because this is where the problem could happen because of the settlement. Earth structure is subject to weathering, subject to weather condition, subject to the flood, and subject to poor construction. There are traditional earth structure which is constructed, and from this diagram you can immediately see how big how additional land had to be acquired for constructing the earth structure, and also how earth structure sort of obstructed the surface activities. Okay. There are other ways like using the reinforced earth structure to support the guideway or the track work. And this is for the purpose of reducing land acquisition, but still created obstruction to the surface activity. Okay, the construction of the earth structure mainly is in its quality of the construction details. Like this contact surface had to be very clean, and they had to be very well compact, or basically you had to compact it and you had to cut it back in later on to the firm ground before you can construct the second there. And you have to do this in a good weather. Raining day is not suitable for doing it, and you have to provide enough water. You have to provide enough slope to drain out the water in case the water start accumulate in the interface. Okay, so these are some of the details, and so construction of the earth structure mainly it's cheapest of all the structures, but it requires highest quality control. Okay. This again, I show you some of this construction of this earth structure in Taiwan, and the bench had to be made at some height. With each certain height, you have to have a bench, and you have to have drainage cut off in order to collect the water. And then this, all these construction details have to be carefully carried out. Okay, again, this is a view of the for the earthwork which is constructed on the valley before entering into the tunnel. The track work is sitting on the earthwork.